In today's video, we're going to see MultiSig wallet. MultiSig wallets are basically smart contracts where transaction needs to be confirmed by multiple wallet addresses and only then it can be executed. So these kind of wallets can be used for vaults where 3% needs to confirm a single transaction before it gets executed. Let's see how it's written. First, in the variables, we'll take owners. Owners are addresses of parties that have to confirm. And we'll take number of confirmations required to execute a transaction. And let's create a transaction object. So it should contain to whom we are sending the ether and what is the value of the ether that we are sending. Bytes of data in case of we are calling a smart contracts, but in case of transferring the ether, this will be empty. A variable to see if it is executed or not, and a variable to keep track of all the confirmations that it received so far. In the constructor, we have to set the owner of the smart contract, and we also have to set the minimum number of confirmations required to execute a single transaction. So the number of owners should be always greater than minimum number of confirmations required. So let's put a check for that. And the length of owners should be always greater than 0. Now we have to insert these owners to the owners array. And we have to set number of confirmations to this one. Now we have to write functions for submitting a transaction. So this is called when we want to submit a transaction to the smart contract that needs to be approved by all the wallets, all the owners. And we also need a function to confirm the owner's approval on the transaction. And we also need a way to execute the transaction when the enough number of confirmations are received. So let's complete these functions. When somebody submits a transaction, we have to put the data into the transactions in an array called transactions, array of transactions. Let's create an array of transactions here. So a transaction. So transactions are array of transaction. So here we have to push the transaction into the transaction array. So we have to convert the transaction into a struct and push it into transactions. So to confirm the transaction, we will be needing the transaction ID that we need to confirm, which is index in the transactions array. Here we have to check the transaction is not already executed. So we have to get the transaction. And we have to increase the transactions count by 1. And here we have to update that the owner has already confirmed the transaction so that he doesn't confirm again. Let confirmation be a mapping, and here so we have a transaction ID is mapped to, and each transaction will have multiple owner addresses, and we will mark each one as true or false whether he has given a confirmation or not. Here let's check if the address is already confirmed by this owner, and also set it to be confirmed once the transaction is confirmed. So this should always be false. If it is true, we have to say that the transaction is already confirmed. Here we have to check whether the transaction has a minimum number of confirmations or not, and then execute if it has a minimum number of confirmations. Let's get the transaction and check whether the transaction has a minimum number of confirmations. When execute function is called, we have to set the transaction executed to true. We have to execute the transaction using the call method. It returns the value success, the first value of the tuple. So we can identify whether the transaction is succeeded or not using this. If the transaction is not succeeded, we are going to revert back the transaction. So all these functions can only be executed by owners of this smart contract. So let's write a modifier to limit the usage of the functions by the owner. So in this modifier, we have to check whether the message.sender is the owner or not. For that, we have to maintain isOwner mapping. So we have to fill this is owner every time when we are creating the owners array. So we can check whether a particular person is owner or not. This needs to be true. If it is not owner, this will throw error. So we also have to write a receive function so that this contract can receive ether, so that it can distribute the ether from this contract. So I'm deploying this contract. I'm setting two addresses as the owners. And number of confirmations required is 2. And the contract is deployed. And we have two owners at 0 and at 1. First, let's send ether to this wallet. So the transaction is confirmed. So the balance of the wallet, the balance of the contract is 1 ether, and let's submit a transaction to transfer this to a different wallet. So I want to transfer this to this wallet. In case of ether transfer, we don't need to pass any data. I want this owner to submit the transaction. So the transaction is submitted now. So at 0, we have a transfer of 1 ether to this one, which has received 0 confirmation so far. And when we try to execute the contract, 0. So it failed. So the transaction is not confirmed. So let's give confirmations to the transaction. So let's confirm transaction 0 with the first wallet. Yeah, we have received a confirmation. We have one confirmation. Let's give one more confirmation for transaction 0 with my second wallet. Now we have received 2 confirmations, and now let's try to execute the 0 transaction. Yeah, we're able to execute the transaction and send. What we have sent is 1v, not 1 ether. We can see this transaction on chain. So this is the transaction that we have sent. So we have sent 1v smart contract to this address. So this is how we can set multiple signatures to send a single transaction. Hope you have enjoyed. Let's see you in another video.